Welcome back. Module 3, weight and balance, loading in extreme conditions. Weighing the aircraft. Okay, in this objective, the learners, you're going to be able to identify the standard weights of the aircraft, and then you should be able to, when I give you the specifications and the weighing data, you're going to accurately be able to calculate the aircraft's empty weight, the center of balance, the center of gravity range. We're going to be able to calculate all of that stuff. There's some standard weights for weight and balance that we need to take in consideration. You'll find that in a textbook, or you'll find that in the AC 4313. Aviation gasoline is about 6 pounds per gallon. Turbine fuel is a little heavier at 6.7 pounds per gallon. And lubricating oil is 7.5 pounds per gallon. But remember, most of our oil systems are serviced in quarts, so we'll have to take that into consideration. Should you have a water tank and it needs to be filled, water is going to be at 8.35 pounds per gallon, and then the standard weight for crews and passengers is going to be 170 pounds per person. As we get into smaller aircraft, though, I want you to remember we're going to actually calculate the physical weight of each individual person. For large commercial airlines, we're talking on an average 170 pounds per person. An example of weighing an aircraft, let's look at our Cessna 150 we have in our picture here with a tricycle landing gear, and we've got floor scales in front of us. We're going to roll the airplane up onto the floor scales, and you can see we've got the computer there in front of us, and we've got each cable running out to the left gear and to the right gear and to the nose, so you can see, and then we've got our computer box in front of us, and we're going to be reading what each scale weighs for the left main and the right main and for the nose. So that's going to be our current example. Specifications for weight data, we're going to be looking at the aircraft datum. For this particular aircraft that we have in the video, the leading edge of the wing is going to be the datum on this aircraft. Now the 150, remember we had talked, the datum for the 150 that was in the previous picture here is actually the face of the firewall. But let's move back to this aircraft here, and for this purpose here, we've got the datum. You can see the datum line coming down right there at the leading edge of the wing. We're going to level the aircraft. Remember, as we get ready to weigh the aircraft, we want to make sure the aircraft is in a level condition, just like it would be for flight. So on the side of the fuselage, below the window, there's going to be a couple of screws that are actually stuck into the fuselage, or maybe you just got a couple of screw holes there. We're going to find those two holes. We're going to actually put some screws in there, and we'll put a spirit level on that. Probably going to want a 3 or 4 foot spirit level. Put it on those holes, and then what you're going to do is you're going to adjust the extension of the landing gear or the inflation of the tires to get that aircraft in a level condition. Specifications for weight data. Let's look at our numbers here. We've got our datum, or 0, is at the leading edge of the wing, and then from the leading edge of our wing to the center of the main landing gear, it looks to be about 70 inches. The nose to the main is 100 inches, so we're going to back up 30 inches from the datum, or a negative 30 inches. So you got a negative 30 for the nose for datum, you got a positive 70 for the mains. That gives us 100 inches forward to aft between the nose and the mains. Our fuel capacity, 30 gallons. Remember, I think we said fuel weighed how much? Let's look. Aviation fuel, 6 pounds per gallon. Let's go back to where we were. Okay, so 30 gallons at 95 inches datum, or 95 inches after the leading edge of the wing. 30 pounds, that's 30 gallons at 6 pounds. That should be, what, about 180 pounds of fuel if it was a full load. And then unusable fuel is going to be 6 pounds, or about 1 gallon at the 98-inch mark. Oil capacity is 8 quarts at a negative 38, or 38 inches forward of the datum. All of this information that we're pulling right now, we're going to find on the type certificate data sheet. The right main tire, when we weighed this aircraft, it was 640 pounds minus the tare weight of 5 pounds. We had chocks on this aircraft to hold it so that it didn't come off of the scales, and the chocks weighed 5 pounds. During the weighing, the fuel tanks were full and the oil was full. So prior to 1978, we'd have to deduct the fuel, 30 gallons at 6 pounds per gallon, And then we would also have to take and deduct the weight of the oil, depending on how much oil was in there. Remember, we said that was going to be where? Oil capacity, 8 quarts, 2 gallons, 38 inches forward of the datum. We can use a hydrometer to actually check the specific gravity of the fuel. You check it against what the specific gravity should be on a standard day, and then we determine that the fuel is actually close to 6 pounds per gallon. It's 5.9 pounds per gallon. So you'll take that into consideration. On a small aircraft like this, not going to make a whole lot of difference in the total weight. Very, very minimal. When you get into large aircraft where you're talking thousands of pounds of fuel, that's going to make a big difference. But for a small aircraft like this, we're kind of showing you that we would use a hydrometer, but again, this type of aircraft, we would just defuel it and be done with it. If we can't defuel the airplane before we do the weight and balance, we probably need to reconsider our priorities. But the hydrometer check does show you that it could be done if we had to do it. And again, if the airplane is weighed with full tanks, the full fuel is subtracted, and then the unusable fuel is added back. Based on a hydrometer reading of 5.9 pounds per gallon times 30 gallons, and we can do the math, we can calculate that out and find out just exactly how much weight we have. Okay, so let's look at our datum, analyzing the data that we have. Our main wheel center line, we said from the datum, from the leading edge of the wing back to the center of the main wheel is 70 inches, or an arm of 70 inches from the datum. The nose wheel, the arm was a negative 30 inches, or 100 inches forward of the main wheel. Notice we didn't give you a measurement from the datum to the nose. We gave you a measurement from the main wheel back to the nose wheel. But we were able to calculate that out as a negative 30. Okay? And then calculating the empty weight center, calculating the empty weight and the empty weight CG. And we'll look at the chart below. These charts are really handy. If you have these charts available, go ahead and be sure to fill them out as you're calculating your weight and balance. So let's look. We've got our nose weighs 225 pounds. We had a tare of 2.5 pounds, which was our chock, so we have to take that away because we're not going to fly with the tare weight. So we had a net weight of 222.5 pounds, an arm of a negative 30, or a total moment of a negative 66.75. Remember, that's a negative twisting. Remember, we said the moment is a twisting torque. You can calculate the left main, you can calculate the right main the exact same way. It's okay that the left main and the right main don't weigh the same. You've got different stuff on each side of the airplane, but that's all right. So the left main was 650 pounds, the right main was 640 pounds, and giving us a subtotal weight of 1,515 pounds. When we subtract the tare from that, or the chocks from that, we come up with 12.5 pounds. So our total weight of our aircraft, the net weight, is 1,502 pounds, or 1,502.5 pounds. Giving us a total weight, and then we need to subtract from that. Remember, we said we had 30 pounds of fuel, so we're going to subtract the fuel at 5.9 pounds per gallon, or 177 pounds. Then we have to add back in that gallon, or that 6 pounds of fuel. The oil is full, so that's acceptable. Remember, after 1978, we're going to calculate weight and balance using a full oil tank. So we have a total weight of 1,331.5 pounds. We do the arm, we add the arm up, so we don't add the arm up, I'm sorry. Let's back up. We've got our total weight of 1,331.5, and we've got our moment. We calculate our moment if we come over here on the side here where our moment is at. Let's look and see. We've got our nose, it has a moment of 66.75, that's a negative. Our left main has a moment of 45,150. Our right main has a moment of 44,450 with a subtotal, add all three numbers together, of 82,925. We subtract our fuel, and we add back in our unusable fuel, and we have a total moment of 66,698 for a total moment, or a total twisting force of 66,698 inch-pounds of twisting force. We know our weight, and we know our moment. So remember here, and we go moment over arm times weight. Okay, and let's look and see. We have a weight of, what did we say, 1331.5, and we're going to divide it by 66,698, and we should come up with a number, give or take, 50.1. 50.1 is our arm to our center of balance. That is where our center of balance is going to be, is 50.1 inches. So let's flip back at our airplane here as soon as I get this mess off the board. And let's look and see how that, get all this off so you can see me. Okay, so if we take our leading edge of our wing, and we go back, how far did I say we were going to go? We were going to go back 50.1 inches. If we go back 50.1 inches, it looks like the center of gravity is actually going to be just forward of the main landing gear. If that falls within the type certificate data sheet, then we're good. Remember, we're going to have a CG range. It's not going to say it has to be at exactly 50 inches, but it's going to say, you know, it's going to give you maybe a 4 to a 6 inch range, and maybe your center of gravity range should be like 47 to 52 inches. And so long as you fall within that CG range, you're going to be fine. If for whatever reason you don't fall within that center of gravity range, then we're probably going to have to start double checking our math, make sure all our numbers are right. We want to make sure that all of our numbers here are right, make sure that all of our distances from our datum are accurate. Okay, so we've calculated the center of gravity range to be at 50.1 inches, and we find that that is within our range area, and so we're happy with that. The center of gravity we determined, like I said, is 50.1 inches, and notice here what you're typically going to find in your aircraft charts. If you look, notice the circle with the black and the white kind of X in the middle, almost looks like a propeller with a day and a night, if you will. That is kind of our symbol to show the center of gravity range. To summarize this module, we should remember that we had some charts that had some standard weights. A standard weight for aviation fuel or for jet fuel, the standard weight for passengers. Everything has a standard weight. We should remember what those were. You should remember that we used a chart that we would actually put our numbers in. What was the weight of the nose jack, or what was the weight of the wing jack? And then we should be able to also have in that chart your arm, and then you can calculate the moment. Remember how we calculated those charts and we took away the tare weight? If we were using platform scales, or if for whatever reason we had tare weight on our aircraft, we would want to add that to the chart to make sure that we remove that tare weight from the total weight of the aircraft. Remember to account for any residual fuel. If the aircraft, if it's just unusable air fuel on that aircraft, we're okay. But if we didn't, if we had other fuel load on that aircraft, we need to take that into consideration to make sure that that's removed from the total weight of the aircraft. Because remember, what were we calculating? The empty weight, center of gravity. We need to subtract any tare weight, anything that is on that airplane that would normally not be there during flight, whether it was chocks or things of that nature. Then we're going to go ahead and calculate the center of gravity. We should be familiar with that six item chart that we had, and you should be able to use all those numbers on that chart to accurately calculate the center of gravity, or accurately calculate the empty center of gravity of the aircraft.